Hi everyone, in this tutorial I'm going to be guiding you through how to solve R and S in a chair structure, if that is what is provided to you and you're asking, or being asked I should say, to determine the configurations of the asymmetric centers. Now the trick here is that you will actually convert the chair structure to a perspective drawing. You could maybe start with this carbon that's bonded to the bromine. The bromine is up, so we're going to make that a solid wedge. Then going around counterclockwise on the ring, 1, 3, you should have a chlorine, and notice how it's also up. Therefore, we go around counterclockwise 1, 3, plotting the position with the chlorine, and then counterclockwise relative to it, 1, 2. There's a methyl that is also up. Therefore, we give it the solid wedge. So now let's solve for the R and S. We're going to start at the carbon with the bromine. Okay. So at that carbon, the hydrogen is back. Therefore, we have priority 1, 2, and 3. Take a second to try to solve those yourself. Hydrogen's 4. This looks like it's S, and it will be S because the lowest priority is back. Going now to the carbon with the chlorine. Here's the asymmetric center. We have priority 1. Then we have carbon, carbon, hydrogen. Hydrogen is 4. The carbons tie initially, so those become our visual reference points. This carbon on the top is bonded to HH carbon. Again, it's just one atom at a time. HH carbon. And on this side, we have an H, a carbon, and a carbon. And 2 carbons beats 1 carbon. Don't get visually distracted by that bromine. We haven't gotten to it yet. Therefore, priority 2 is this carbon, and priority 3 is that one. We have 1, 2, 3, counterclockwise. This is going to be the S configuration. What we see is what we get because the lowest priority is back. And lastly, we have our final asymmetric center, the carbon with the methyl group. Let's clean this up just a little bit before we get there. Okay, do it in a different color. We have the H, our implicit hydrogen on the dashed wedge. Got to put back our chlorine. We have at the asymmetric center carbon, 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 hydrogen. Hydrogen is 4. This carbon is bonded to a chlorine, which is a high atomic number atom. That would be a carbon just bonded to hydrogens, and a carbon bonded to carbon, and 2 hydrogens. So we have 1 carbon bonded to hydrogens loses to this carbon, which is bonded to a carbon. We'll have priority 2 and 3. We now have 1, 2, 3. That is clockwise. That is the R configuration because the lowest priority is back. What we see is what we get, and we have the R configuration. Okay. Now, it's a little bit difficult to just look at the chair structure and do R and S, which is why I'm a huge advocate for first taking the time to convert over. Remember, anything that is up, whether it's axial or equatorial, whether it's up, you put it on the solid wedge, and if it was down, it would be a dashed wedge group. You will then do R and S in the perspective drawing and fill in the respective configurations.